Before we get started, if you haven't subscribed to the channel, please consider subscribing. In this video, we will take a look at how to work with census microdata, and we will, for the purpose of demonstration, we will estimate a labor supply equation using the 2006 Canadian census data. Now I'll go back to the guide that I've been following here. So we can come up with different reasons why we want to subset, but I will not get into those details because that depends on the context of the research question or the analysis that we want to conduct. So here we have those things written down that you can pause and look at why I'm doing for this particular tutorial. But let's get into the main analysis. So we want to estimate a labor supply equation using OLS. The dependent variable should be either hours per week or hours per year. So it can be found by multiplying the hours per week by weeks worked in the year. And for the right hand side, we want to use a wage variable and a non-labor income variable. And we can use one of the family income variables along with someone's particular own wage and salary income. And then it asks us to explain why we chose the variable. So again, this shows that there are multiple different variables to work with to answer just one research question. And so it depends on how we use what variables and how we make those decisions. So here I have a quick explanation here, and then I'll get into the code. So I first create the total hours variable, and before doing so I drop observations for which observations are 98, or weeks worked or hours worked equals to 999, and 999 stands for not applicable, and then 98 stands for folks who have reported 84 hours of work or more during the reference week. Okay, after this I have this much of observations which we can take a look at, and then we generate a dependent variable as annual hours worked. And then for the right hand side variables, I have a wage variable, and then I have a non-labor income variable which is generated by turning household income variable into a continuous variable following the instructions below and subtracting wage income from that. So we take the total household variable which is given in discrete steps in the data set. So we will take the midpoint between the upper bound and lower bound of the steps, and we'll convert it into a continuous variable, and then we'll subtract the wage income from that household income, and then the difference is going to be assigned to be the non-labor income for that particular individual. All right, now we can go back to the script and see how we do that. So we generate hours, H is equals to hours worked times weeks worked, and we drop if wages is not applicable. All right, let's run this bit, and the code worked fine. Only 101 observations got deleted. Next, we want to generate a non-labor income variable in this data set. So we first start with a placeholder, one variable that has missing values that we're going to replace with actual values that we estimate. So we want to use a loop, and we assign non-labor income values to household income categories 1 to 8. Again, we can refer back to the data dictionary to see what these different household categories mean, but I won't get into that part because the whole idea here is to see how we can use data to analyze these data sets. So here I'm generating non-labor income equals to I, which is the household income, right? Equals to I, and so I start with 1000, and every time I increase I by 2500. So for someone whose household income is equals to category 1, their non-labor income is going to be assigned as 1000, and then in the next iteration I is updated as 1000 plus 2500, and then we move on to the next category of household, and then we assign 3500 for them, and then we move on. So that's what this loop is doing here. And for those who are in household category 9 to 20, what I'm doing here is I'm taking the household income to be 80,000 and then adding 5,000 every step as we move up the household categories in this data set. And for those with categories from 21 to 28, I'm manually entering their non-labor income. So we can do this using a loop as well, but here we have like a example of both ways. One way using a loop, and a different way using manual entries, whichever is more efficient for the purposes of our task. And we're basically taking the midpoint of the ranges that is given in these household incomes. So I will run this whole code block together. One thing to keep in mind is that when we are running script from two files, if we have loops, we should select the whole code block together and then run it all together instead of running individual lines from the two file. Because if we do run individual lines, Stata forgets the memory that's the variables that is stored in the memory. So we should run the whole code block if we have loops in the two file. Okay. And we can see that has been done. We can see our new variables have been created here, non-labor income, household, and so on and so forth. Last we want to do is we want to subtract the wages from the non-labor income to get the actual non-labor income, because right now what we have is the total household income, and we want to subtract wages from the household income, and we assign that as a non-labor income. All right, once we run this, we now have an estimate of non-labor income, and we have an estimate of wages that comes available with the dataset. Drop if non-labor income estimate is negative. And then we get into the analysis. So we can go back to our guide and see how we are doing this analysis. Essentially, we are going to take log transformations of the variables, and we are going to estimate a standard labor supply equation. And that equation is log of hours equals to intercept plus beta 1 times log of wage plus beta 2 times log of nonlinear income. And here is the result. And then we can use these estimates to also get the static elasticity of substitution, or the income elasticity, or the compensated elasticity of substitution. So very common topics in labor economics. So let's get into it. We are generating the log transformations of these variables. Here's the script. Now we are regressing a standard labor supply equation. So we don't have any control variables. We are just regressing log of hours over log of wage and log of nonlinear income. I'm using a robust standard errors, and we can use the outreg command to export the output into Excel file or a Word file or a text file. So this is a regression, and we can use these coefficients to estimate labor supply elasticity. So once we use the outreg command, we can see here I have the outputs. This is how it will come up in a text file. We can also save it in an Excel file so that we can copy and paste them when we're writing our papers or our results. And this is the script we'd use to save the output as an Excel. And here is our compensated elasticity of supply. And this is our estimate, 0.533. The formula is taking the beta of the log of wage minus beta of nonlinear income times wage divided by nonlinear income. And we can do a variety of justice as well, but I won't get into all these in this one video. We can make a separate video on that. Basically, this is how we read this dataset, the census dataset. Very important is to understand the data dictionary to identify the key variables and their meanings. And then this is how we can transform the data, and we can estimate a standard labor supply equation. If you like my videos and find them helpful, then please support my work by subscribing to the channel.